Hello, thanks for coming out to check out our talk. My name is Sky. I am a project manager at Supertone. Yeah, and we'll be talking about AI-driven content creation and how we are planning to bring voice synthesis to audio applications. So to give a short introduction of ourselves, Supertone is a young startup. We were founded 2.5 years ago, and as you can see from our slogan, Intelligent Audio for Creativity, our goal is to bring the next generation audio technology to creators with a focus on highly expressive voice synthesis. Our research can be roughly divided into 3 categories: voice design, voice content creation, and interaction and communication. And all the topics you see up here are pretty actively researched in the field of artificial intelligence. Ultimately, our goal is to combine the result from all this research and create a technological stack that, used together, can serve as a complete tool set for creating and modifying the voice. On top of research, we're also developing software products based on our research. And currently, we have one plugin out in open beta. It's called Goyo. It's a voice separator plugin. And yeah, you can go check it out and download it for free. So try it out. We'll come back to Goyo in a bit. Other products that are currently in development, without getting too deep into it, are Nest, our voice designer, Canary, our voice content creator, and Raven, our real-time voice changer. So we're thinking that voices that are designed in Nest could be used in Canary and Raven to create a wide range of voice audio content. So that was a brief introduction of who we are, and for today's talk, we'll be talking about the following topics: advancements in AI voice synthesis, production challenges, and what's next for us in terms of our journey to create next-gen audio tech. So yeah, let's jump right in. Here's a general landscape of voice synthesis at the moment. On the left side, you see applications that are more meant to deliver information through audio. So you see like navigation, weather report, kiosks, and stuff like that. On the right-hand side, we are kind of plotting these applications as more inspirational or creative. We see video games, vocal editing, and digital artists and stuff like that. Previously, with existing voice synthesis technology, it was kind of difficult to create stuff on the right-hand side, but with recent advancements, we're seeing voice synthesis expanding more and more into these fields. And obviously, this is the area that we're most interested in. So previously, each voice synthesis application has been treated as a separate research topic because they normally require different inputs. But we've heard from creators that this is kind of difficult for them to work with. Creators normally need a tool that can handle a range of inputs. So this is why we made a unified voice synthesis framework. It's called Nancy. And Nancy can generate voice from a range of inputs. So it can take raw audio recordings. It can take symbolic data like text or musical scores. And it can also take semantic information like age and gender to generate sound. And Nancy can also take control of each element of the voice. We divide the voice into 4 elements: timbre, linguistic content, pitch, and loudness. And Nancy, using Nancy, we can pretty much pick and choose where we want to change the voice. And this gives creators a lot of freedom in terms of getting the right voice for their specific use. So yeah, let me show you how Nancy performs various synthesis tasks within a single network architecture. So here we have singing voice synthesis from symbolic data. On the top, you see a musical score. It's a score for Fly Me to the Moon, and in our case, we have a MIDI file of this song. And then we have a target singing voice. In this case, we have Elvis Presley singing Amazing Grace. Let me just play you a sample of this. Amazing grace, oh how sweet is the sound, that the sound. Yeah, so Nancy isn't trained specifically on Elvis Presley's voice here, but we are taking this roughly minute-long sample of Elvis and then applying it to the MIDI score, and this is what we get. This is Elvis Presley singing Fly Me to the Moon.
Fly me to the moon, let me play among the stars. Let me see what spring's like on Jupiter and Mars.
Yeah, so that was 100% synthesized voice. Thank you. Yeah, and Nancy is not trained on, like hours and hours of Elvis Presley singing. It's pretty much just taking a minute of his song and applying it to the musical score. Next up, we have an example of vocal performance in different voices, and I'll go just place the video immediately.
Hi, I'm Claire, and I'm an intern at Supertone. Here's me recording some fake commercials.
This is for elegance, for beauty, for serendipity.
This is for the new generation, the cool generation. This is
for you, the all-electric CVC-1 by Supertone Motors.
Yeah, so that was our intern Claire, who was kind enough to agree to record this fake commercial, and then we took a random target speaker and then just applied their timbre to her speech sample. And again, Nancy has not been trained on either of their voices. This is a zero-shot conversion. We found an interesting case where we could use this model and actually put in the target speaker and the source speaker as the same person. But then if we pitch up or down the source speaker's voice, it actually applies their original voice to the pitched sample and makes it sound like they sung that song in that pitch. Let me give you a quick working demo of this. So here we have... Oh, it's already loaded. So here we have Adele singing Rumor.
But rumor has it he's the one I'm leaving you for.
Yeah, so let me just go ahead and pitch this up like 5 semitones. Oh, that's 6.
But rumor has it he's the one I'm leaving you for.
Yeah. So this is Adele's song, like her voice reconstructed based on the source sample of her singing that's pitched up, and then the target sample of her original voice. Let me push it to an octave higher than the original, and we can see what happens. Oops.
But rumor has it he's the one I'm leaving you for.
Yeah, so I think anyone who has used like pitch editing software will know that, an octave higher normally creates like a lot of different artifacts, and here we're seeing that it sounds a bit more natural. Obviously, the voice model reconstructs the voice, and there are artifacts, but it's sounding a lot more natural. We can go an octave below and see what happens.
But rumor has it he's the one I'm leaving you for.
Yeah. And then we can also try to do some other fun stuff like lengthening a note a lot. Let me just, pop in a few edits here and there too.
But rumor has it he's the one I'm leaving you for.
Yeah, so that was an example of changing the pitch or duration of the notes dramatically using Nancy. Next up is zero-shot text-to-speech synthesis. So we have this text that's 2 sentences, and then using a TTS model we can generate the sound. And then we have these speakers that will take the timbre from and then apply it to the TTS sample. So let me just play a speaker sample here.
And for virtual characters in the metaverse, no more voice actors needed, as content creators can easily create any voice.
So some of you might have noticed that is our intern Claire, also again kindly providing her services. And then we're going to apply Claire's voice, the timbre of her voice to the TTS sample.
Supertone innovates the content production landscape through state-of-the-art AI technology. Thank you for visiting our booth and enjoy our latest technologies.
So yeah, again, Nancy has not been trained on Claire's voice, but it is able to, based on this short sample, kind of pick up her speech patterns and then apply it to the TTS sample. And then using this, we can imagine a scenario like this, which is a post-production script editing, where we take the actor's voice and then apply it to a TTS sample to kind of edit the script in post-production.
Now look, just because I wouldn't get no man a foot massage, don't make it right for Marcellus to throw Antoine off a building into a glass motherfucking house, fucking up the way the nigga talks. That shit ain't right. Now look, just because I wouldn't get no man a foot massage, don't make it right for Marcellus to throw Antoine off a building into a glass, funny-looking house, messing up the way the fella talks. That stuff ain't right.
Yeah, so that was maybe too much profanity for a fine event like ADC, but yeah, we've toned it down to a PG-13 version for you. All right, so this is our last demo. This is how we're thinking about maybe approaching voice design. So based on our database of a number of voices, we are able to extract some meaningful axes like gender or age, and we're able to travel seamlessly among these spectrums. And I can just play you this video.
Supertone innovates the content production landscape
through state-of-the-art AI technology. Supertone innovates the content production landscape
through state-of-the-art AI technology. Supertone innovates the content production landscape through state-of-the-art AI technology.
Supertone innovates the content.
Yeah, I think you get the point. So yeah, so I've shown you, a number of applications of where our voice synthesis research can be applied. But it would be no use if these technologies weren't packaged into applications that creators, musicians, artists can use. So for that, I'll introduce ChangHun, a developer, and he'll talk more about some of the challenges that we face into bringing these technologies into production.
Yeah, I'm ChangHun. I'm a software engineer of the Supertone, and it is an honor to represent our great team and our great work. I'm going to tell you guys what kind of challenges might be encountered during making a cool AI technology product. So let's start over. This is a brief pipeline of how it works when we were integrating an ML model into a final product. First, our research design a model and prepare a data for training. Then next, ML engineers design APIs to handle those trained models, and also do some optimization of a structure and data flow models. And then the developers implement the front-end part of the APIs and model into a proper product, such as an SDK or plugins, web application, etc. I'll cover more detail later. So our first product, Goyo, is born from this pipeline. Let me introduce Goyo. This is our first attempt to productize our ML model into a plugin. Goyo means calm and tranquility in Korean, so it's kind of metaphor that plugin tranquilize noises and make the voice clear. It is real-time voice separator which can denoise and de-reverb, even de-voice for each simultaneously. It is powered by a lightweight but very well-trained ML model and obviously runs in real time. It is on beta, so it is provided for free. So please feel free to use it. Yeah. Let me show our demo. Yeah. So, oops. Okay. So this is quite reverberant sound source, and let me show you.
Right through the beginning of the war up to.
So this is the original sound of the source, but if I
had decided that
reduce the gain of the reverb, then
for their oil. So they set about building a number of oil tanks across.
Quite drier.
And this in Shandong is one of them. The construction required 6 tanks to be built. The entire complex could easily contain 100,000 tons of fuel oil. But one single Royal Navy battleship could drink 5,000 tons. So it could go very, very quickly.
Yeah, or maybe we can hear only reverbs. Yeah. And other one is quite noisy sound. Hello?
2018. Now go change the world. Merci.
Let's change it up loud. Yeah. Here you go.
Class of 2018. Now go change the world. Merci. Class of 2018. Now go change the world. Merci.
So this is how it works. And it only needs the one source, and it separates into the 3 channels: ambience, voice, voice reverb. So you can download our website, and it is for free. Yeah. So let's start over again. Slideshow. So we had several challenges on both research side and engineering side to make it run in real time to Goyo. Firstly, the neural network must be designed with the consideration of real-time processing, so which means only a short period of look-ahead is allowed. So for speech enhancement, the UNet architecture has been widely used since it is 2-dimensional convolutional blocks cause a long latency. So we've got to modify it to be a causal so that the I/O latency becomes less than 40 milliseconds. Also, the model needs to be efficient, so we decomposed the input into multiple bands through a filter bank. Yeah. And of course, the good data is the most important thing for training a model. We gathered lots of data, voice data and noise data for recordings, and as well as many impulse responses for simulating a real world like noisy and reverberant environments. The next part is how we're going to deliver our AI technologies to user. We are using this chart to determine what kind of or how we're supposed to select the form of the product. We put so the Goyo, our first product, places here, which has causal system and has low computing cost model, and there is kind of limitation that real-time software might have. Despite the large complexity means can process a lot of things got done well, but we must compromise the model size to get it done in real time. Real-time processing has technical limitation that we can only know the data from past. Luckily, speech enhancement can be done by between this circumstance, but still the limitation keeps ML model away to do something much better stuff. But things are changing these days, thanks to the ARA or thanks to the juice. Now we can develop non-causal audio plugins. It brings us the possibility to accomplish a task which requires the whole context of data, such as context of phrase or context of singing voices. Yeah, something like that. It is a huge paradigm shift, not only for traditional DSP plugin, but also for ML-based software. Furthermore, if it requires more large-size model, we can consider a GPU acceleration for inferencing, and also can consider a cloud API integration if we have to handle a huge non-causal model. So, and another thing is to choose the proper inference engine. There is already a good acceleration framework for ML, and all we're gonna have to do is just choose the right one. Besides, we want to serve our technology not only for a plugin, but such as SDK, to make it available to implement anywhere, PC, mobile phone, portable devices, something like that. So what to choose depends on what kind of platform are we gonna target. Apparently, Onyx runtime more fits in various applications, but if needs to be implemented on AMD processor, especially with Neon, then TF-Lite is much better choice according to the benchmark. So once we choose proper inference engine, then we export the research code written in Python into the optimized model, which powered inference engine we choose, and write some native code to pre-process and post-process the audio data for this model. It is necessary to implement it in low-level code since it should be run fast. There's one more thing which has been quite frustrating, but well known. So this was the first result that our research team have done and how I implemented this to a code. And one day the research team found that they can reduce more complexity of model if divide model into several smaller models. So let's say goodbye to my original code. I have to grind up the whole logic and reconstruct it like this. because the entire model and the structure of in-out parameter was totally changed. Actually, they shouldn't care how it's going to happen to developers when change the entire structure of model, because they should concentrate on how to improve model. Scientists. Yeah. This kind of disrupt happens almost every single day, so it is not that new to us audio developers, right? As I mentioned before, this is our pipeline, but it is obvious that each of these steps could be a bottleneck to each other, so I'll tell you about that. Firstly, the new model's data flow was quite complicated and hard to understand. So our development team, including me, spent lots of time to get it done in native code. Secondly, while I was testing if the new model still works fine, I found some cases which is not working as much as the first model did. So actually, it can happen anytime since the neural network cannot point out which data should be processed to which exactly. So of course, consistency of the behavior should be obtained somehow, but it is really a hard job to achieve in machine learning. So I reported to ML engineers that there might be some issues on training, so they did some investigation and finally found that there was a small mistakes. And also research team might get this feedback from the ML engineers again too, such as model performance is so poor, or there is not enough data for model training, and so on. Yeah. So basically, these are all the bottleneck and pain in the neck. Speech enhancement task is quite simple, but as you can see, it is not that quite simple when developing it as a product. It is not the only problem when developing a ML-powered product, but it can also occur developing any other things than many other different people are in charge. So what I'm trying to point out is this is not the problem that cannot be solved, or this is not a problem only occurs in ML engineering, but we are always struggling to solve these issues. Interestingly, I found that there are many people who have similar concerns as us in the ADC22, such as C major or Newton. Yeah. So I think we'll be able to introduce our approach with happiness. So this is our approach. What I try to do is to integrate those processes into one single framework. I'm not going to mention why we choose the graph-based UI, because it is obvious. This framework is for research scientists, basically, so it makes quick to prototyping and development with ML model, designed to generate the low-level codes from user-designed graphs, and it designed to, and it supports node several types, such as scalar type or signal data type for time or frequency data, or ML-friendly data types, such as tensors, something like that. And lastly, provide visual debugging and profiling so we can help to make processing graph can run on real time or not. With this tool, we expected to shorten up the development cycle by eliminating a bottleneck from each step. For example, research scientists design a graph to define how signal data flows into neural network. Then ML engineers keep optimizing a neural network, which goes into the ML node in graph. We believe that to make better tools for creator, we should innovate ourselves first, but it is still in progress. But these attempts will come together and make our audio software better. I hope to share more about this, but our time is running out, right? So feel free to visit our booth out there, and there is more further information. So I'll hand over my mic to Sky.
Cool. Hi. Is it okay if we go like a couple minutes over, or? Yeah, I think we got like 4 to 5 minutes left. Yeah, thanks. Okay, thank you, Ricky. So we covered some of the advancements in the field of voice synthesis, and then how our most recent effort at developing a plugin went, as well as how we hope to improve on the process. So what's next for us at Supertone? We're seeing a huge surge, as I think everyone else here is seeing as well, of products powered by AI really starting to be used in the creative fields. We're excited to be part of this wave and contribute as a key player in voice synthesis. And with our strong research team, we hope to develop audio applications both in-house and in collaboration with some trusty partners to bring our technology to creators. And speaking of creators, being here at ADC, we're constantly reminded of how the creators really need to come first, and how we always have to keep them in mind when building these technologies into products, so that they can be used in a fun way, in a free way. Yeah. So before we let you go, we'll show you a sneak peek of what we're working on for our next audio application. It's called Raven, and it's a real-time interactive voice conversion tool. So let me show you real quick.
Check, check. Hello, hello, yeah. So I see some familiar faces. I think you've come and checked this out at our booth, but I'll just go right into it.
Well, check, check. Hi. Yeah, so this is Raven. This is our real-time voice conversion tool. It's we're thinking that this is going to be for musicians, streamers, virtual YouTubers, streamers who want to protect their identity on the online sphere, as well as people who just want to sound a little different to match what they sound like, most themselves. So yeah, this is Nancy. Hope you find it interesting. We're hoping to ship this as a product next year in one form or another.
Thank you very much. Thank you very much. Really amazing. Incredible sound. Do we have any questions? Yeah.
Thank you. Very impressive. Do you have plans now or in the near future to add any kind of safeguards, software, hardware, or otherwise, so that you can avoid abuse, like the equivalent of vocal deepfakes, for example?
Right. Yeah, we're having a lot of we've been having a lot of internal discussions about the ethical aspects of voice AI. I think the most important thing is never using a voice unless explicit consent from the owner of that voice. That way, most of the scenarios where this goes wrong is when someone's voice is used without their permission, obviously. We're also working on, like audio watermarks per se to detect if this voice has been synthesized using our technology, so that we can prevent misuse.
Sorry, I'm not used to this. Watermarks are a great start, but obviously, as you rightly said, you want to address the edge cases with bad actors. So in addition to watermarks, do you have other ideas to further subvert those kind of attempts?
Well, yeah, as I said, I think this really would have to, get baked into the product or the frameworks that we're building. We're, exploring all kinds of options in that realm. Thank you.
That was a great presentation. Thank you very much. I'm going to ask the classic ML question in that what training data did you use for, in particular, the singing synthesis? How did you acquire your own, or did you use open source?
Actually, this question might be answered with our CTO. Could you help me?
So you asked about the data set, right? Right. So yeah, we collect publicly available data set, but there's only a few data set with the correctly labeled data, which is MIDI data, including note transcription and lyrics. So we have to try to generate our internal data ourselves, and it's very hard work because singing transcription is a little bit hard work for not for the everyone is, but yeah, some kind of labelers or annotators has to be well educated in using DAWs or something. So yeah, so we are trying to make a breakthrough with on research side. So our Nancy framework can also make a very efficient way to using the data set to. So yeah, that's my answer. So if you have any if you want a more further discussion, please visit our booth and we can make further discussions. Thanks.
I can see quite a few questions. Unfortunately, we're running out of time. So I hope you can catch up with Supertone.
Yeah, visit our booth,
But yeah,
please.
thank you very much.
Thank you.